On the screen share, I want to share.
मेरो क्लास भइरहेछ हेर न यस नाइ 8 बजेसम्म हुन्छ आज
Everyone for joining the talk, especially Surya. As he said, he has been a friend of mine, co-workers since I worked with Orlink in 2007. So thanking Mountech and Surya, I would like to start my presentation for today. So Aditya, we're going to talk about audio video streaming in Python. But before we start about doing it in a Python, I would just like to tell something background, give some backgrounds about what is audio video streaming in general, right? So once we have that some data, then we'll talk about how it's been done, what are the underlying layer of audio video streaming, and how it can be done within the Python itself. So today's agenda for my talk would be what is audio video streaming in general, then what are the protocols and codecs that be used within the audio video streaming. So there, when you talk about audio video streaming, it comes down with different components. It comes with software-based streaming. It comes with hardware-based streaming. We'll talk like in detail of what it makes its difference between software versus hardware. Then we'll talk about components of AV streaming, because in our day-to-day life, AV streaming has been impacted a lot, and it's been seen everywhere. So we'll see what are the different components being used by different companies on to do the AV streaming. Then eventually we'll talk about if we have to do something like that, how it is possible to do it within the Python. So let's talk about audio video streaming, right? So when you say about audio video streaming, what is in fact audio video streaming? What's happening? Sorry, it's the wrong side. What's happening in the audio video streaming? So यदि कसैलाई लेम्यानलाई भन्नु पर्यो भनेदेखि audio video streaming भने के हो भनेर भन्नु पर्यो भनेदेखि it would be something like there will be a source which will be capturing something somehow, and there will be a destination that somebody will be viewing it, and somebody will be watching it. But the thing that happened on the source and the things that happen in the destination has to go through a lot of more different layers. So all those different layers combined is audio video streaming. The whole layer that goes through from source to destination is audio video streaming. There are so many components to it. There are so many things to it. It's not like straightforward camera on garera, I want to go live in Facebook when you're live someone is watching you live. That's straightforward, like you're doing it on real time. But in fact, under the hood, there are a lot more things happening. And so that's what we're going to talk about, like what different things it's going to happen. And next thing is, who's using AV streaming? AV streaming. Who are the end user for it, right? So the answer for that is everyone, each of us joining in the meeting is the customer of AV streaming. We use AV streaming in our day-to-day life. It's a part. It has been a part of our life. So you talk about YouTube, you talk about Facebook, you talk about YouTube Live, you talk about Twitch, you talk about Bigo, you talk about TikTok. Every company that I mentioned, and every video that you watch today is a part of audio video streaming. Even the IPTV box that we have now in Nepal that has been next to your room or in your TV is using audio video streaming. Back in days it was analog streaming, but now it's come down to digital streaming. But the AV streaming is there as well. So everybody, like in this world, we are using AV streaming in our day-to-day life. We don't give much more attention to it, like how much back-end thing is there that's happening. But it's been there. Um, so, so if we are all using this audio video streaming, what are the components involved to it? Like how I talked about, it's all about source and a destination and to deliver the content from source to destination. But how it's been happening? Like as a developer or as a technical person, how that things is going from one end to other end. So that's when it comes in protocols and codecs. So anything you can think like you are in Bangalore and you want to go to New Road, right? So what are the options you have? So your Bangalore is a source, your New Road is a destination. You can go by bus, you can go by micro, you can go by uh, motorbike, you can go by car. There are different ways of going from one source to destination. So from one source to another source, same as source to destination. And also in AV streaming, there's the same thing. There is a source, there's a destination. But which one do you want to choose? Um, you want to, so that comes in which protocol you want to choose. So for AV streaming, and also in network general, we have two protocols that defines TCP and UDP. So you can use either of these two protocols to streaming from source to destination. But the question is, why TCP? Why not UDP? Why UDP? Why not TCP? Again, that depends upon what you want to do. So if you want to go on taxi, let's say for my previous example, from Bangalore to New Road, if you want to go on taxi, the cost over there is you got to pay more for a taxi, but you're going to eventually reach to the New Road. But if you go on a bus, the cost over there is less. It takes more time, but eventually you reach to the New Road. But the question I would that need to answer in choosing the protocols is what do you want to achieve or what you are trying to achieve from sending a stream from one source to another destination. Is it time efficient? Is it um, um, is it for the quality? Is it for the time? What are the, because as every coin has its two sides, there is always a downside for each thing. So in that sense, you got to make a decision of what you're going to choose on the protocol side, TCP versus UDP. So again, I'll talk about this more in detail in the later with other slide. That's when it comes in handy. But for now, let's say there are two protocols that are available, which is transporting from source to destination. That's TCP and UDP. Now comes after the TCP and UDP, what are the codecs you're going to use? So the codecs here are the data that's been captured on the source and that has to be delivered on the destination. Could be on any form. Um, that's because bandwidth is very expensive. So that bandwidth needs to be preserved. We don't want to lose any quality, but at the same time, we don't want to use heavy bandwidth while transporting your data from one end to another end. So that's when the codecs came in. Codecs basically encode one form of data to one certain specification. And the other end will read that specification coded data and then export it out. So as in the slide, everyone can see, I have put out some audio codecs. So within this codecs, ELA, EULA, and GSM, even Opus, these four codecs are used for transporting a data in a mostly on a real time. That's being like, let's say, if you're talking in a Viber, you are saying something and your other party is hearing something. You can put it at like the source and destination. So in that case, the codec, mostly the codec has been used, the codec that's been used for audio would be EULA. Some cases it might be GSM, but it's been the most used codec on the industry. For if you are watching something on a YouTube, then the audio codec would be AAC, because that's because the most used codec for video transmission for the quality is AAC. So these are for the audio codecs. So now for the video codecs. So what are the different video codecs that we use for transporting from point A to point B? So back in days like 1990s, S.263 was a popular means of codecs. Then in 2000 till last decade, it was S.264 was a highly used codec. And again, these are for only video transporting from one end to another end. Then it had come to HEVC, which is the ingoing right now. Like everybody is using HEVC codec, which is also known as S265 for transporting data. And 3GP, Theora, and QuickTime is like a decade-old codecs that was one time they were in hype, but they were one of these codecs that could be used to package the content together and then send it out from one source to another destination. So this is about the protocols and codecs. So now we learned about uh, streaming, how it's been done, point 1 to point 2. So if you need to send from point 1 to point 2, what are the protocols, what are the ways of sending it? So ways is you need to choose a protocol, how to send it. You got to choose a codec, how to send it. We haven't talked about the protocols. There are different protocols that we're going to talk about. Um, but choosing of the codecs. So now codecs and protocols. These are totally tied together with different aspects. So for an example, let's go to the previous slide. TCP. Let's talk about TCP protocols. So if you have to choose for the TCP protocols to stream a data from source to destination, what are the TCP protocols we have? So one, we have RTMP, which has been used heavily. Um, and it's still being used, though RTMP has been out of the market since couple last year, but Flash has been out of the market, but not the RTMP. So it's been used heavily. Now, when we talk about TCP protocol and RTMP protocol, what their specification tells is there's a set of codecs that we can use to transfer the data on that protocol. And that set of codecs would be for RTMP, would be either SPIX, Nelly Moser, or AAC. That's for audio codec. And for the video codec, it would be either BP6 and S264. So again, this is, you can think about the protocol being a pipeline that is used to deliver from point A to point B, but the data that's gonna be within that pipeline comes with a specification of that protocol. So what kind of codecs that protocol can handle. And the RTMP, it could handle Nelly Moser, SPIX, and AAC, and also the MP3, sorry, as an audio. And S264 and BB6 has a video codecs within its pipeline. That's the example of the TCP protocol. Now, another protocol that works on TCP is HLS. Um, HLS is a protocol developed by Apple, and it's been used to deliver content from one end to another end within the HTTP protocol. Right? It's also called HTTP live streaming, HTTP live stream. So it's been used for delivering the same thing, content from one end to another end over HTTP, which uses TCP. On the TCP example, on this case would be MPEG-DAS. Same as HLS, MPEG-DAS also does the same thing for delivering the content from one end to another end, but it uses a different specification over the TCP protocol. So these are some of three of the examples that transfer the data from one end to another end within the TCP protocol. Now, talking about UDP. So what are the UDP specification does? If things are doing with TCP, why do we need UDP for streaming, right? So the thing is, for UDP, like for an example, let's say if you are in a Viber call and you have been making a call to your friends or buddies or somebody else, and you're saying something, but the other party is not able to reach, something happened, some glitch happened within the network and something happened, and your data is repeatedly broadcasted to the other party. That will be too much annoying for the other party to hear, because in real-time communication, you don't want the packets to be redelivered if just in case if the packet is lost or some network glitch happen, because it will be too much irritating. Um, so that's one example of the UDP protocol where it comes in handy is if you are doing a real-time communication and if you are making a real-time delivery of a stream, but you could paid off the lost packet, but you don't want to retransmit the packet like an like a uh, I mean having a call with somebody else on the other end. That's where you use the UDP protocol. It's still a streaming. It's streaming. It's taking a content from one end to another end. It's doing what's the TCP protocol does, but within the UDP protocol is it's not guaranteed that protocol is going to be reached to the other end. If there will be some packet, it's going to get dropped off within in the middle if there is some network glitch happen, and we don't worry about that packet um, because we want to move forward with what's coming next than repeating the same packet again. Versus in TCP, that's not how the TCP works. TCP will try to retransmit the packet again unless it's get the final acknowledgement of it's been delivered. Um, so talking about a UDP, what are the different protocols within the UDP? So within the UDP, the protocols are RTP, SRTP, RTSP. So all these are being used by the UDP protocols. And also the big noise that we are getting it lately is WebRTC that also uses the UDP protocol. Um, so when is the UDP protocol handy? If we are making some real-time communication, like using a Viber, using a WhatsApp, or having a real-time communication, that's when the UDP comes in handy and uses that protocol. Um, so within the TCP, we have a protocol for audio like Nelly Moser speaks MP3, AAC. For UDP, we have a protocols like ULA, ALA, GSM, Opus, and things like that. So now this is about how the things been delivered from one end to another end with protocol and the codecs like encapsulating it whole thing. Now we'll talk about back to our same topic, audio video streaming. So while doing audio video streaming, so how do we package this thing and deliver from one end to another end, right? So how this thing happening? We talk about, okay, these are the things that needed to stream these components, but how is it happening? So that's when comes two things. There is a software encoders, there is a hardware encoders. So basically software encoders are you are running an application within your computer or you know a, a proprietary computer that just does the encoding in a software level, meaning it's going to use your GPU cycle to do the encoding for how you're going to stream it. And there is a hardware encoders, which they don't use the software or CPU cores to do the encoding, but they rely on the hardware component of the hardware devices that does it for them, and then they use it. So, like, and for example, the good example of the hardware encoders would be in a TV channels, like let's say in Kantipur television or image television or any television. If you have ever gone to that television newsroom or even television place, you see a lot of analog devices over there, and those components are all hardware based. I don't know now they have might change to software based, but it's hardware based. So the switching happens between the ads and the serials, or even the news happens, the cutting of the scenes in between, everything happening in a hardware level. So they are just switching from one place to another place, mixing it together, making a logo on top of the feed that's been captured from camera. All those things are fetch into the hardware system with different input, and then somebody sitting there with a master switch of mixing it together and then sending it out as a one stream, and then that stream is eventually even either digitized and then send it to YouTube, or it's been sent analog, transferred to analog signal and sent it over the thin air. So that's where it's mostly used. And also I mean, that was an example that's been mostly used, but it's been used with the studios, like the big studios, if they want to go live. Like for example, let's say there's a concert happening right now somewhere in Nepal, and they want to go live. So what the component they have to use? They will get the camera, they will capture it uh, with the hardware encoders, where they encode it in a hardware level, and then once that's in the camera capture has been transferred to hardware encoders, they will somehow make it digital, and there will be different components on how to make it digital, and eventually they'll stream it out to the internet. Or in US, how it happens is there is a concert happening, it's been captured on the camera, and then it will go to hardware encoder. From the hardware encoder, now it goes to a satellite with the analog signal. Then from satellite, it will go to the main station hub. They will capture from the analog signal, and then they convert it to digital, and then send it out to the stream. So that's a big example of hardware. Now, what's the software encoders work? So software encoder is basically as I said, it's working on your core CPU and your memory. So some of the software encoders that I know, that I'm aware of, that I've used is OBS or SteamLab OBS. These are the best top software that's been used, software encoders that have been used out in the market as of now. All the gamers that you see on a YouTube or any Twitch or Facebook, they use this. So they use this to capture your screen and then stream it out to YouTube or Facebook or any other platform, right, where they can stream it. So basically, unlike on the hardware, what this is doing is this is capturing your screen digitally, encoding it digitally, and then sending it out to the streaming platforms digitally. So there is no hardware involved into it. I mean, there is a hardware involved because it's using a CPU core power to encode it, but not like has a hardware encoders. Same as FMLE. FMLE is a Adobe proprietary encoder. Does exact same thing that OBS does. Um, Wirecast is a commercial version of OBS. Different company, but only the corporate client, they use the Wirecast because they give you the same encoding functionality from the software base and the XSplit. So name of some of the hardware encoders that been used in the industry are these, like Teracade, Epipan. These are the company that they use. Now, since software technology has been so much advanced, most of these hardware encoders, what they do is they give you a hybrid system. Hybrid system in a sense, they'll give you a hardware that does the encoding and everything on a hardware level, and they will also give you the interface that you can now the thing that you captured, or the video that you captured, or audio you did a capture from um, the camera and put it on your hardware machine, now can digitally transform it out to the internet. So it's kind of hybrid system in there that they have built, and these are some of the examples that they have been used. So now question becomes, why the transition happens between the software encoders and the hardware encoders, right? So the main reason is this: CPU being not that cheap, but at least being cheap in these days, um, and the hardware encoders compared to that, comparing between the cores of CPU that we can get versus the hardware device that we need to use for this encoding is different. I mean, there is always, every coin has its two sides. There is always a downside of some things, right? But hardware encoders are more expensive than doing same thing on the software. But also hardware encoders provide you much more flexibility on what type of things that you can do, or what kind of things that you can ingest in the hardware versus software, because software, they're limited with software itself. Everything has pros and cons, but mostly was the cost. Cost for the hardware encoders are expensive compared to software encoders. So people, when it's where it is necessity to use hardware, they still use hardware encoders. But if The same thing can be done with the software encoders. They would rather buy some powerful CPU computer with a higher core of CPUs and then do in the software layer than do it in hardware encoders. Now that reminds me of another topic called GPU. And GPU is totally a hardware-based thing, which is a graphical processor unit, which has been heavily used on the market lately. Um, again, that's that's is a hybrid of software encoders and hardware encoders, because that GPU can work in between these two components. So you can have a GPU placed on your computer and instruct the computer to do some work on the CPU and some work on the GPU. So with the help of GPU, so GPU is a hard. So if you are instructing it on a GPU, that means you are using a GPU as a hardware encoder to encode it. So GPU stands in between the software encoding and the hardware encoding. It can be used for hardware encoding and then pass the data to the software encoders, or it can just be used as a standalone hardware encoders. So that was the encoders. Now let's see the bigger picture, how this thing is happening, right? So we'll talk about the components of AVS stream. Let's see. So this is a basic diagram for what's happening. So somebody is trying to stream out a gameplay on a desktop to the people for his subscribers on YouTube or in Facebook. So what's happening is the player who is trying to do it, or the celebrity who is trying to stream it out, it's capturing the screen or capturing the content on the first stage. Then it's sending it out to a Facebook. Now there is a component over there. Capturing is one component and sending it out to a Facebook on the component. So the example that I have here is for RTMP and SRT. Uh, SRT is a new protocol that's been still underdeveloped, and it's mutual alliances with Google, Microsoft, IBM, Intel, and all these big giants company. The reason this SRT is getting hype lately is because the royalty for S265 codec is very expensive for them, and these are the platform that the audio or the video has been highly used. So they come up with their own open source protocol, and it's called SRT. But in any case, going to the topic, so if somebody is trying to stream it out from the source to a destination, the component here involved is capturing it on the source using some protocols to send it out to a Facebook or a YouTube. Protocol here is RTMP or SRT. Now the codecs here would be the codec that's supported by the specification of the protocols. Both of these protocols supports AAC for audio and S264 for the video. Sorry, S265 for the video, or S264. Then now what happens within the Facebook is a different architecture. So now the Facebook gets the ingested stream on their system, and they do might be different thing. They might analyze the stream, they might not analyze the stream, just proxy pass the stream to the end user and put it on their browser. That's up to them, but we can talk about that in detail later. But it goes to let's assume it's going to go it going to a Facebook or a YouTube. Then once it goes to a Facebook and a YouTube, eventually the person who's on a cell phone or in a tablet or in a computer who's watching it is getting some stream. Now on that side, the stream would be either HLS or MPEG-DAS. Before it used to be a RTMP, but RTMP is declining down. So the whole industry has now shifted towards the HLS or the MPEG-DAS. And mostly since HLS is Apple proprietary, the company are trying to avoid using HLS and trying to go with the MPEG-DAS. And most of the things is happening in MPEG-DAS. As I know, YouTube is happening on MPEG-DAS, Facebook is happening on MPEG-DAS, Netflix is happening on MPEG-DAS. I haven't checked any other streaming, but these three big giants, they are using an MPEG-DAS. So again, MPEG-DAS and HLS is the same thing that I talked about earlier, sending um, um, data from one end to another end. So if you look closely, there are like a couple of things happening. So the source is not like only sending a source from a streamer to an end user. So there are the component, if you break it down, it would be at first stage, the source is the one who is streaming it out. The destination is Facebook or YouTube. Now the Facebook and YouTube will do the manipulation within the stream, how they want to do it. Since it's the platform to stream, what they are doing is now with that, they are again creating a stream. Now in that stream, the source is Facebook and destination is end users, right? So it's the source and destination has been chunked into two different segments in this case, from streamer to Facebook, YouTube, or from YouTube to end user. That's one of the test cases. Again, if you want to disinvolve Facebook and YouTube out of it, you can straight make it things like, okay, I want to stream it and send it to the end user. You can do that. But since Facebook and YouTube has a platform over there that they provide, using their platform, how it looks like is an example, right? So this is for real-time communication, meaning if you are streaming it out. But mostly if you look the videos on Facebook and YouTube or even in TikTok, these videos are not the real time. There are some of the real times, but not all of our real time. Most of them are the archive files. So how those thing works is same as the real time. So in this one, we use the real time protocol to send the data on real time, like at an RTMP or SRT. But in the other case, when you are watching an archive video, you will be getting the uploading a file, which in this case would be could be AVI file or MP4 file. It depends upon the container, what kind of containers has been used, and upload to a YouTube or Facebook. They will process the file, and eventually out of that MP4 file, they're going to create HLS or MPEG-DAS segments out of it. And anybody who's watching a YouTube video or watching a TikTok or watching a Facebook video is getting this HLS or MPEG-DAS chunk out of it. So it's not the MP4 file being played out, it's a chunk being played out. So these are the real-time example, and these are unidirectional. What I mean by unidirectional is like there is a thing happening, somebody is just streaming it out, and there are the end users is getting the data. So it's not coming back from end user back to the streamer. Right? It's just going one way. It's like a kind of a broadcast system. You are doing a live stream, it's going to out your subscribers. You're uploading an MP4 file, it's going out to your subscribers. So it's a one-way communication. Now, streaming is not about only a one-way communication. There is also a two-way communication. And the good example for that one is a Bigo app. What they do is they give a real-time engagement with the people who's hosting the stream between the other participants. Like for example, the team, the Zoom meeting that we are having right now. Though we are muted, most of the people, almost everybody is muted at this point. But if we unmute, we can have a two-way communication. And this is also streaming, because we are sending a data from one end to another end and from other end to another end. It's a bidirectional communication. So what's happening on bidirectional communication? So this is what's happening on bidirectional communication. So it's example of WhatsApp and Viber. So with the bidirectional communication, the protocols that we use, like for unidirectional is RTMP or SRT for live streaming, and for bidirectional, it's a WhatsApp, or example for WhatsApp or Viber. We are using a RTP or SRTP protocols to do that. So what's happened is somebody initiates the connection from one end to other end, and once the negotiation or the agreement happens between the two end, then the audio video streaming starts flowing between two parties. This is a good example for the WebRTC as well. WebRTC works on the exact same principle as a bidirectional communication. You can make it unidirectional, but it's generally used for bidirectional peer-to-peer connection. Also, this is the same example for how voice over IP works. Um, it's using the same standards as voice over IP is working, and the same protocol as voice over IP works. And in fact, this is an example of how voice over IP works. This RTMP with RTMP protocol with bidirectional communication is the one, which have been used by WhatsApp, Viber, WeChat, and other messaging chats. Now, this is all about theories of what it's been, how the AV stream works, and how things are working. Now, since the topic is about AV streaming in Python, now the question comes back to how we learn all these things. Okay, we understand protocol, we understand codecs, we understood how things works from one end to another end. I understand the protocols, the bidirectional communication, unidirectional communication, but how it's going to use, how we going to make an application that does it, that we can see, okay, we're gonna use. So in order to answer that, so Python by itself won't be able to do anything without help of any other components. So pure Python hasn't have that library to do it for us that can stream it out. So since this is a talk about the Python, I'll be more focused on Python than the core of C, C++, or any other programming language. So going back to my thing, Python, yeah, it won't be able to do that, but we want to do in a Python. So what are the ways that we can do, or we can build something like this, or even make a proof of concept of saying, okay, I streamed this and it's streaming, and I did it in Python, or build the application in Python to do that. But again, Python is a very good programming language to make a product for a POC. It can also still go for production. I have built so many products within the Python that have put down in a production without any issues. But again, in some cases, it might not be a good idea to use Python and have to follow the other programming language. But what we are going to do, is it doable in Python? And the answer is definitely yes. Yeah, we can, whatever I say right now, everything is doable in Python. But what we need to do it in a Python? Like, how is it possible to do it in Python? So let's say if you have a MacBook, you have a Linux system, or you have a Windows system, you install a Python. Now you wanna build something that does the streaming. Can you do that right away while installing the Python? The answer to that question is no, because pure Python doesn't support things that we need the component, all these protocols, codecs, the pipeline to build it. So we need something that could help us to do it. So that's where it comes the frameworks for the thing, for the AV streaming that we build. So um, one of the uh, ways that I have seen people use in the past is um, they wanna, let's say they wanna they wanna read something from a source and then stream out to somewhere as a destination. But since Python doesn't support streaming natively, the one approach that I have seen is what they're gonna do is they're gonna execute some external components that would be able to do it. So for an example, let's say there is an open source application called FFmpeg. What one can do is you can run the application. So if you have a source from the pure Python, you can run an external application, which would be FFmpeg in this case, to do some action. So you know the source where it's coming from. You run the FFmpeg command to get the data from the source, and within the ffmpeg command, the ffmpeg can stream that thing out to a destination that you want to send, and you can execute that from the Python. But is it a pure Python? The answer to that question is no, because you are not doing anything in a Python. That exactly same thing could have been done in a Bash. You could have get the data on a Bash script, or even PHP script, execute it as a system command to some binary function on the system, and pass that argument to a FFmpeg and do it. But that's not a Pythonic way of doing it. I mean, it works if you want to do it, but you don't have a control of what's flowing within the source and the destination. You cannot control the source and destination in that case, but you can still do it. Um, so that's where the Pythonic way, or the Pythonic architecture of doing it comes in. So we are not talking about that part, because that's like kind of executing an external command to do what you trying to solve the problem. But we are trying to get here how we do in a Pythonic way. So do all achieve this and to know it, we need something called glib. Glib, or you can say, so these are just same thing with the different acronyms. Glib, gobject, PyGobject. So what this thing are like, gobjects is about.
अलर्ट देखाइरहेछ त्यो हटाउनु मिल्छ
Oh, sorry.
स्क्रिनमा
मेरो email as.
हस्
Thank you. So glib, gobject, and PyGobject, these are the acronyms for it. So what is it about? So if you are a user of Linux and you have used Genome Desktop ever, so Genome Desktop, when they build a Genome Desktop, there needs to be a libraries that you need, or there needs to be a source code that needs to build that Genome Desktop. So Genome Desktop is totally based on glib, which is structural based programming. It's not C, but most likely is like to C, and it's written. It's the base foundation is C, but they have a different. They have a wrapper on top of C, so they have a different approach of dealing things with the functions. Then comes the G object. So G object is like a C++. So it's a object-oriented programming on top of glib, right? So it makes it C++. For understanding. And then comes PyGobject. So PyGobject is a Python binding for this G objects, which is the C++ version of glib, which works with the framework. So on the slide, as I showed there, so how this thing works is your pure Python won't be able to handle the AV streaming. So you would need something that would help you to do that, or some framework, some libraries that you need, or API that could do that for you. Because you are not going to write whole framework by yourself to do it. It's going to take years and years and years of time. So that's when the PyGobjects helps you. So this so Python. So if you look at how the Python gonna use, would be Python would be calling some PyGobjects, which we have been installed as a framework. PyGobjects will have its own libraries that come when you install a PyGobject will come inside with it. There'll be like an example, as I said, lib GI repository, libg, and all those things. And those libraries already bonded with type lib and the libraries binary file. So what does this mean is so this whole framework is designed such a way that if you are going to write something on a Python and you have installed PyGobject, PyGobject knows how to use the existing library for your Python. So you don't have to worry about it. So if you are going to write same thing on a Perl, you import the Perl GObject module onto your application, and Perl GObject knows how to handle with the library. So basically, the PyG objects that been out there, it's such a robust that you include that PyG object in your application, regardless which programming language you use. Um, Anything that's supported by PyG object has a framework, you will get that library on your application, regardless Python, Rust, Perl, PHP, anything. So it's not language dependent. So that's what the type-lib defines. So if you look at type-lib, it's a set of functions that they defined. It's not a language specific, it's language independent. So any language you want to choose at the left-hand side, instead of using Python or any language, eventually if you're going to use some functions or some classes that written on glib, you can easily access those. And again, those function and those application could have been written um, on a C or a glib, but they follow the same standard of a G object um, um, architecture that they will gonna eventually get it. So the whole point is here is with the pure Python, it's not possible. So you need some extra component to it. The extra component is nothing but PyG objects, and we need that because the framework that we're gonna use is a part of the PyG objects. So while building an application in Python, do you need to know how the Python G object works for doing things? The answer is no. You don't have to know about it. You don't need to know how to code on on a G object. You don't need to know how to code in glib, because it comes everything with the package. Just need to know about how the framework is used rather than how it's been built. I just have it here, so we understand how the things is built. Now comes the core component, the Gstreamer. So this is a framework that we use in a Python to stream the data from one end to another end. Now, if you look at this picture, where the Gstreamer, where the Gstreamer, where the Gstreamer sits is like here, like this one. So like here, libfee is one of the library. You can see on this stack, you can put Gstreamer over here. So it's basically a part of PyG objects. If you install PyG object, it will install it by GST, we also call it. And then you can eventually access it from the Python to PyG object. PyG object will have the PyGST. PyGST will have its own type-lib and binary files, and you can access those things. So talking about the Gstreamer, what it does, like how it's been used to build the application. So there are so many things to it to talk about, and I don't think it's enough for 1 hour, 2 hour to talk it, but I'll go very high level. So like in previous example, right? I talk about source, I talk about destinations, I talk about protocol, I talk about the codecs. So here, if you look at this, so this is a whole Gstreamer pipeline. The core framework consists of its own core data, but they have these pluggable modules that you can plug into the core module. And then with the help of that, you can build any audio video streaming application. So what that means is, like in my previous example, there's a source. I don't think they have given it any destination, but let's see, these are destination. You can plug in source, you can plug in protocols, you can plug in codecs. Now you can plug in destination. Okay, this is a destination, things are destination. So basically it's giving you everything that you need from the source to destination, and it's available out there. So this tool can be used with RTP protocols, with the UDP protocols, with any codecs that's been out there in the market, as long as it's been supported. It can be used for unidirectional streaming. It can be used for bidirectional streaming, anything. So it supports voice over IP and video conferencing, and it also supports for video editing. Like for an example, mm, Adobe Premiere, how the video editing is done. Same thing can be done within the Gstreamer. Now the question is it open source? Yeah, it's definitely open source. And is it easily available for to try and test it out? It is. It is open source. It's available on free on the GitHub, I think, and they recently changed it to the free node or something. I forgot the website, but yeah, if you look for the GitHub, they have a GitHub repository over there, and it could be available. And there are tons of different documentation out there in the internet that you can read up. So this is a framework that we're going to talk about. So we don't want to go much more in details into it, but I'll just give you high level examples of what this thing does. So this is, so we call everything we call in the gist on the streaming is a pipeline. Everything is a pipeline. As I said, there's a source, there's a destination. So if you think about the pipeline, it's always a source and the destination. So within that case, so Gstreamer Pipeline has an architecture where it sends different events, queues, and messages. What does that mean is like for the context of an application from a running from starting point to ending point, there's some information being sent back and forth between the bus and between the application to know what's the state of the application, and that's what it's been used for, very high level. So how does, okay, if I want to stream, how I will be able to stream it out on the Python using it, or without the Python using it, let's say just for the Gstreamer doing it, right? So for this one, this is an example that I have. So what this example is doing is, this is a source, we are reading a source. So if the source has a audio stream and the video stream, that means the source is composed of two channels or two stream in it. One is video and audio. So what this component is doing is it's reading the source. The source is getting the source where to get it from. This is deplexing at the content, so it's gonna spare out the audio component out of it and a video component out of it. Again, this is an example for one single audio and single video. It could be like one single video and 5 different audio channel with different languages. So it's, you might have seen here 5 different thing, but it's make it simple. And then with that, you are sending it out to a video sync or the video destination or the audio destination, right? So to make it simple, what's this happening is you can think of a player that we are having it. So if you have an MP4 file on your computer, you open the MP4 file, put it on a media player or any VLC player, that's going to play out your MP4 file. And how that MP4 file is being played is exactly in the same context. It's reading the file, demuxing the audio and video data, and then playing it out individually. Now there is some mechanism how to synchronize these two data together, but we can talk that in much more depth in later talks, but that's something mechanism is happening. So if I have to do that without using a Python or just installing a Gstreamer, how would I do that? So this is a basic example of how we do that without getting hands dirty on a Python, just with installing Gstreamer by on the system. So what's happening in here is it's getting a file source, is decoding it. We're giving the name as a decoder for some name. We're converting the video, because once you decode the video, it's going to be a raw format, but we're converting it so that the other element can accept it. So one thing I forgot to tell here is, so these components here each component is an element. So these components here is a component over here. So it's each block is an element. So it depends upon what kind of element you want to fetch it over here. So for now, my requirement is I want to read the file. I want to stream it out to my computer. So for that, my component that I need is I need to read the file. I need to decode the file. I need to convert to the file so that my computer plays. This for the only video and this for the audio. I need to read the file. I need to decode the file. Once I decode the file, I have two channels. One is video, other is audio. Video, I want to send it to my video screen. Audio, I want to send to my audio channel. So this is how it's been done. So to see if how we could do that, let me show you something on the demo here. Like how is it possible? Where is my, okay. So I'm going to do exact same thing that's happening in here. So we're gonna do GST launch file source location equals to dbb.mp4 estimate out to decode pen. The name it as demux video converting it, doing audio auto video sync. Yeah, so with that, just that thing, I'm playing the video over here, but definitely I'm just dealing with the video part here, not the audio part. Let's make it more interesting. Let's add the audio part in here. Now while I'm playing it back, I just want to do also the audio auto audio convert and do auto audio sync. I don't know you guys can listen or not, but it's playing on the back on my laptop.
Yeah, we can listen.
Yeah. Okay. So so that's been done with the basic command prompt with the framework, right? So now that's not what we want to do, and this talk is not about how we want to launch it on a CLI command to build it. We want to do it on a Python. How are we going to do it on a Python? The exactly same thing we did. Now here comes the Python application. So in order to do that in a Python, as I said on the previous slides, we need to have a PyG object installed. And with this PyG object installed, it comes as a GI repository. It's a Python package that comes with the Python G objects. And we need to install the GST for the Python. There are documents out there how to install the GST for the Python. We call this the main component here is GI, which is a G object introspection. This is an in charge of getting a request from the Python and then transferring it over the library files that's been installed on the system, or transferring out the functions to a library files which has been written on G objects, and getting the real time the function accessible from Python that's been written on G objects. So we need that. So being said that, so we need to have GObject introspection being downloaded. So now once the GObject introspection is there, we just need to define which version we want. It's other version is not supported, so 1.0 is true for now, and it has to be there. Then we need GST. This is because we wanted to build now this application in Python, so we need the GST for that. Then we need a glib. Why do we need glib? Because this whole thing has been built on top of glib, so there are some components on the glib that we need to start for our Python. Then now next thing, so once we import those, next thing is we need to initiate it. So we just said, okay, GST init. We can give a name to it, but we don't want to give name. So we just say, okay, let's initialize the GST application for that. It's been done. Now that's been done. This is the basic example. The main core component and here is, I'm pretty sure it's going to be too much technical information to go through this. I'm just giving very high level how that could be achieved. So one thing is, as I said, everything is a pipeline. So even in the Gstreamer, they say as a pipeline. The pipeline is source to destination. We define pipeline. That's the main core component that we need to do. We define a bus because everything that's happening within the pipeline is going through a messages between the bus. So we need to know that. And we define the main loop because everything, since this is a happening, it's a loop, event loop application. We need to have a loop to run. Once that's been done, we need to watch our messages been coming in to our bus because we're going to do some extra activity depending upon what kind of messages we get through from the bus. So we know the state of application, as I said, where it is. So with that, now we come to an element part. So whatever we did in the past, now we are making it on a Python. So we are defining source, we are defining how you want to decode it, we are converting it, how converting the video, how we want to convert, and then we are sending it out to the destination. So with that, this is how you convert. But this all thing has a property. Like for an example, let's say in this example, there is a property. I would say file source, but there is a property for it. Okay, file source, but which location? What file source? What kind of file it is? So there is an unanswered question to that. So we need a property for this element. So how that thing happened in Python is you create an element here called file source element, and you define the property for that file source as a location of where it's gonna go and get it. And here it's a decode bin has some callback functions that we had for added. This is basically what it is like. When the Gstreamer application runs, it runs on a different state. It initializes, it p-rolls, and then once the buffer started filling out to each element, then it starts driving the pipeline. But at the initial stage, there is no data flowing in until the pipeline starts consuming some data. So in that case, we create a callback like this. So basically, the purpose of this callback is when there is a data flowing within the element and it's available, go to this function and look for it, what to do. So an example. So this is a function is going to look, and this is an example. So in this function, if I look for what's coming in, if it's coming in video, I'll send that pipeline to the video route. If it's coming as an audio, I'm sending that pipeline to an audio route. Simple as it is. Now then comes the function about this callback messages. Why do we even watch the callback messages? So for that one, there is because we don't know what happens within the stream if we don't look for the callback messages. So this will tell us, okay, what kind of messages we've got. So if it's the end of stream or UAS message, we can stop it. Like for example, let's say if you build a video player, and if the file stop playing at the end of the file, you got to know the file stopped playing. So then you can just minimize everything and say the video has ended. So for that, for example, let's say if there is a networking issue and you have some buffering happen, or you are not getting enough data, then you can give some message or do some preloading of buffering animation or something like that. So for that, so there are different use cases of using the messages. And eventually when everything is set, you can just say, okay, this application has event loop run. Now let's set up pipeline to playing and see how it's going to work. So basically the whole pipeline here is composed of 6 elements: source, decoding, video convert, and syncs. Now, if we have to look this on a Python code, how it look like? Here's the one. I know where is this coming from. I don't know. Where is it?
The whiteboard.
Yeah, I don't know where is this coming from. Can't I erase this? Okay, never mind. That's fine.
Use गर्नुभएको छ तपाईले कुनै function?
No. It's fine. All right. So what is it? Yeah. Doing this on a Python code is this how it's gonna happen. So we have an import. We have a class. We defined, as I showed on the slides. Then next phase, these are the core components that we need to define. We need a pipeline, we need a bus, we need a main loop. You need to do this for any streaming thing that application you're gonna build. These are the requirement things. You can make it in a different way, but I choose to be in this way. Then we have components like a file source, decode bin, video convert, audio sync, audio convert, and audio sync. These are the thing, the components, element that we need to build. Now each element needs to be tied with other element. So if I go back here, so you can just create these elements and imagine it's going to work. This element needs to be tied with each other. So this needs support. This needs to have that capability that this element can support, or they can ingest it. This element on this side has to support for this element that it can ingest it, and so on and so forth, right? So in order to do that, then you need to link it. So these are just the properties. This is just a fail check I'm doing, but these are the properties. Now we need to link it. So we need to link each element to all the elements, and then add it to a pipeline. So this is a main pipeline that's gonna eventually add it. Once that's been done, there's a callback to go which route we want to go. There's the callback messages, what we're gonna do, and then eventually when it ends, it's gonna quit the whole thing and pipeline goes to ready position. So let's say, so yeah, if I run this application, which is written in Python, it's exactly the same thing that I did with the command prompt, but it's the Pythonic way of doing it. Now if I run it, so it's running it. So this is a Python version of it. The same application that I built with the command prompt, now it's doing it on a Python, right? So what's the advantage of it? So advantage of it is anything happening within these components out here is basically this object. Now I have access of that data. What are you gonna do with it? So I can manipulate that data, and I can do what I want to do with it. So I'll show that how the manipulation gonna happen. I think we're 1.5 hour already in this talk, so I'll just make it quick. So this is not a good example of showing how the manipulation is done. I'll have another example of showing how the manipulation is done, and this is this example. So this is the pipeline that I built to do something like, let's say, what the OBS Studio does for live streaming. OBS Studio does it as an application for the GUI interface and everything, but for me, I build it for just for the purpose of this talk and just to show how the manipulation is happening. So what's happening in here is there are two components happening. I'm capturing my desktop, what I'm sharing, and also I'm capturing my camera. I'm putting my camera on top of my uh, video that I'm capturing it, and I'm sending it to the Facebook. I'm sending it to the YouTube, and I'm sending it out to the. I'm saving it to the locally. That's what I'm doing it in here. Explaining each of these components in details is out of scope. It's very detailed thing that we need to go on each of these things. But this is how general the pipeline looks like. So let's do it on a Python. So then after we can take some questions. I'm pretty sure there are some questions, but I'm gonna just share that over here. So here. So that diagram that I showed earlier with this, this diagram is all about the Python, this Python code. So it's getting the screen source. It's getting a screen. This is a screen source. It's getting a camera where it's gonna get. It's moxing the camera feed with the screen feed, and then also getting the audio capture from my MacBook, and it's streaming it out to the Facebook and also streaming it out to the YouTube. But do we want to do YouTube? Let's try doing YouTube as well. Okay. Again, this is very too much technical. I don't want to go in details because we don't have that much time. But I just want to show how it's been done with the Python. So for that, what I need is some parameter. So first, I want to just go here because I was testing something. I don't want to give alpha to my camera. I just want to make it on. So for Facebook, I have everything ready. For YouTube, I need the data. So let me get the YouTube. YouTube. And I'm gonna reset this anyway. Your videos probably. YouTube Studio. Okay, fine. Go live. Stream Classic. Go to live control room. Yeah. Okay. Test unlisted test. Okay. So I have this YouTube being shit here. AR YouTube. Where's YouTube? Stream key. Copy. All right. I don't care. I'm gonna set it anyway later. Come on. Okay. So what's happening in here is basically, come on. Kidding me? It's getting clicked. Okay. So what's happening is in this diagram back, I'm getting my screen, I'm getting my webcam, mixing it together. We also call it as a moxing. and then creating a S264 encoded data, and then sending it out to the different destinations, YouTube and Facebook. So that's gonna be happening. So I'm gonna start it. Okay, yeah, run it. So let me see. Okay, so it started. So we have this pipeline, the pipeline. So in this pipeline, we have a source and we have a destination. Source is my computer with my camera. Destination is Facebook and YouTube. So now if we go over here to see that, this is what we are getting on a Facebook, sorry, YouTube. This is what we are getting it on a Facebook. So this is exactly the same screen that we are seeing right now. And this is in, if I make it full screen, this is exactly what we are seeing it on the Facebook at the same time that we are streaming, and everything that's been written is from a Python code, sending it, capturing it to the end. Now, the interesting part, as I said earlier, there are two components: me sending it to the Facebook or YouTube, and Facebook sending it to an end user. Well, this happens to be myself in this case, but let's look like what they have been doing to it, right? So if you look at developer tools, if you look for networking, look at all these segments. So these segments you see, and you look at this MPG file. This is defining that the content that I'm sending it out to the Facebook is using RTMP, because I have used RTMP in that, and I can verify that by showing the link information over here. I'm using RTMPS for the Facebook. I'm using RTMP for the YouTube. That's been verified. How this been delivered to Facebook and YouTube? With the RTMP protocol, which works on the TCP. How it's been get to my desktop or for the previewer? Using the MPEG DAS, because they uses the MPD manifest file over here. And again, 2.2 nodes, source being me, destination being Facebook or YouTube, source being Facebook or YouTube, destination being browser or the end user. So that's what is happening in here. So this is how the stream happens on the real time with the Facebook and YouTube. So going back to the slides, it's exactly the same thing. We create a source, we create a audio source, we create a camera source. Let me show you something that'll be interesting. So if you look at it here, though I haven't stopped it. If I stopped it, and if I look at the file, because I'm also locally capturing it, this is the file that I captured. So if I reveal it over here, and if I try to play this file, oh shit. So it's the exact same recording that was happening. So it's playing it back. So basically, what happened is one source, multiple destination is streaming it out using a Python with the help of some G-objects libraries. So this is exactly the same thing. Converting video, converting to S264 codecs in this case. We are using protocol as an RTMP. We're muxing it, everything together, and we are sending it as a destination to RTMP sync and the file sync. So these are some parameters that we need to set. It depends upon the requirement. Different requirement has a different, could be different pipelines, but this is what I have been used so far. So these are some properties for my camera that I captured. These are some of the encoder setting. So I was talking about the software encoder was hardware encoder. We have a software encoder, which is X264 encoding. And these are some settings for the software encoder, like how we want to encode the data and then streaming it out. These are my settings for to do that. Each of this property has this definite meaning to it. So for an example, streamable true is like saying this is not a OD file, it's a live streaming. byte stream is like I want to stream my content as a bytes. Adapt and B adapt is like kind of saying so in any video frames you have P frame, you have I frame, you have B frame. B frame has intermediate frames between I frame and the P frame, so we don't want to have B frames. So this is false. Speed preset is how fast we want to encode it. More faster, less quality, less faster, more quality, depends upon the requirement. Bitrate, we want to bitrate how we want to stream it out. Key integer max is like what's the key rate interval, because if you look at the video stream, it's nothing but just a single picture at a given point of time. With the moving picture so fast within the second, we see it has a video stream. So the same thing, like, okay, after how many each frames as a picture frame you want to have a keyframe. So that's component for that one. After that, just set the property for where you want to send. Like for this example, the Facebook URL, and this for the YouTube URL, and this was for the local URL, and they were streamed. I think that's it. That's what it's about.
Thank you very much, Shishir sir. It was really interesting talk today.
Mm-hmm.
I could learn a lot, at least. I had no idea how audio video streaming works, but from this talk,
Yeah. So I don't know I have any questions or not, but
yeah, definitely. I think we have some questions. So if anybody has any questions, please raise your hand and ask.